All right, in today's lesson here, we're going to take a look at a question from the 2007 AMC math competitions. This is a pretty common question in general, but it does show up in the 2007 AMC. I thought I'd take it up here. So what's going on here is, the sine of A plus the sine of B is equal to the square root of 5/3, and likewise, the cos of A plus the cos of B is equal to 1. They want you to find the cos of A minus B. When solving a question like this, the first thing to take a look at is, what is the cos of A minus B? Well, the cos of A minus B is going to equal the cos of A, cos of B, plus the sine of A, sine of B. So that means what we have to do here is I need to find an expression for the cos of A times the cos of B, and likewise for sine A, sine B. So given these equations, the only thing really you can do is if you were to square both sides, that'll at least generate, you're going to square the first, that's not going to help us. You square the last, that also won't help us, but when you do the first times second times 2, at least you have the product expressed, and the same can be said about this equation as well. When you do the first times second times 2, you'll end up getting at least a factor of the cos of A times the cos of B. So let's go ahead and do that first. So squaring both sides here, you end up getting sine squared A plus 2 sine A sine B plus sine squared B is equal to 5/3. And doing the same thing for our cos of A plus cos of B formula, we get the cos squared of A plus 2 cos A cos B plus cos squared B is equal to 1. So the idea here is we want to find out what this expression here is equal to. Well, I have a sine A sine B and I have a cos B there. So what I'm going to do is I'm going to actually add both of these equations here. If I view this as equation 1 and view this as equation 2, we can add both of these equations. At least this expression will be in the sum of these two equations. Doing so gives us the following. So going ahead and adding these two equations here, notice I put the sine squared A and cos squared A together. I then did the same thing with the sine squared B and cos squared B. I put those together. The reason I did that is that sine squared A plus cos squared A is 1, and likewise sine squared B plus cos squared B is 1. So this expression right here just simplifies to become a 2. And then on the right-hand side, I just went ahead and added the 5/3 and 1, give me 8/3. Continuing on here, you'll notice I can then bring this 2 to the other side, and I can common factor a 2 out of this expression here, giving us the following. And you'll notice here, bring that over and reducing, I end up getting 2/3 on the right-hand side, factor that 2, and we have exactly sitting here, this is your cos of A minus B formula, exactly. So I can go ahead, divide by 2, and we have our answer. Going ahead and dividing across by 2, I get the sine of A plus the sine of B is 1/3. That is the cos of A minus B is equal to 1/3. All right, for the following question here, they give you cos 20 times cos 40 times cos 80, and they want you to find an exact value for this expression above here. The idea with this one here is you want to use the following formula to your advantage. So I want to be able to incorporate that into my expression here. So I'm going to make the following observation. Using our double angle formula for sine, I know the sine of 40 degrees is equal to 2 sine of 20 degrees times the cos of 20 degrees. I can then isolate for the cos of 20, getting rid of this and expressing this as sine 40 over 2 sine 20. Let's go ahead and sub that in to this expression and see what we get. Going ahead and taking the cos of 20 degrees and getting rid of that and substituting that in, as you see down here, with the sine 40 over 2 sine of 20, we end up getting the following expression here. And you'll notice right away you have the sine of 40 and cos of 80 now together. Taking a closer look at that, we observe the following. That sine of 40 times the cos of 40 can be expressed as sine of 80 divided by 2. And again, the reason for that is the sine of 80 degrees, using our double angle formula, is exactly equal to 2 sine of 40 degrees cos of 40 degrees. So let's go ahead and make that substitution, getting rid of the sine of 40 cos of 40, expressing it as sine 80 over 2 gives us the following. So subbing that in here, we get sine 80 times cos 80 over 4 times cos of 20 degrees. And again, we just do that trick again. I can go ahead and write the sine of 80 times the cos of 80 as sine of 160 over 2. And again, the sine 80 cos 80 is equal to the following. Substituting that in, our expression now simplifies to become the sine of 160 over 8 sine of 20 degrees. Now you'll notice here, if you take a look here, the 160 and the 20 degrees, that adds up to 180. Whenever you have angles where there's some of those angles in an expression add up to 180, 90, 360, there's usually a correlated angle that you can apply there. And the identity that we're looking at here is it turns out that the sine of 180 minus theta is equal to negative sine of theta. Therefore, we have the sine of 160 degrees is equal to the sine of 180 minus 20, which is equal to the negative sine of 20 degrees. So let's go ahead and do that substitution and see what happens to the following expression. Getting rid of this sine of 160 and replacing that with negative sine of 120, we can see our sine of 20 degrees cancels, and our final answer is negative 1/8. All right, that concludes today's lesson on evaluating trig expressions. Thank you.